All right, let's get started. Good morning, everyone. I'm Matt Stevenson. I'm the Vice President and General Manager here at Sunstone Circuits. And I'm very excited to have our good friend, Mr. Bob Tise, PCB design engineer from EMP Shield, join us today. We're going to talk things PCB123 related. Designing for success. How do you keep your files straight, both from a designer's as well as a manufacturing engineer standpoint? And how do you keep everything in a row so that you can be successful from design all the way through production? So I'm going to pass it over to our good friend, Mr. Tice, and he is going to give us some 1, 2, 3 tips.
Good morning, everybody. Bob Tise here. I'm just going to go over some things that have bothered me over the years, things that I've found solutions to, and those solutions. So let's get started. First off, one of the things that's always fun is file management, keeping track of not only where are my files, what are they named, and how do I communicate that information to my manufacturing folks or customers that have a problem with a thing and they want to tell me, something about their boards. First thing I need to know is how do I find the exact file that I use to create that board, and then how do I get that information to them. Manufacturing wants a bill of materials for a specific board. They can tell me exactly what board I need. Well, the way to keep that all organized and intact is to just name everything the same and copy that information to everything that's related to that board. So in order to do that, the first thing I have to do, I'm going to share my screen. The first thing I have to do is name the file. And I give it a name that's, serialized, in all the way to the timestamp that I created it. And I will turn that on right now. And here I've got my file name. Copper key, that was handy. There's my file name, then right down to the minute that I saved the file. I saved the file with that name, then I select that text in the file name in my file system, copy it, Control-C, and then I open my design. I set my select filter to text only with assembly or with the silk screen layer, so that I can, on my boards, I put it on the bottom typically. But if you only want to pay for one layer of silkscreen, you can always put it on top. But I just put it on the bottom to get it out of the way of everything, so it's easy to find on the circuit board downstream. Then I do a right mouse, properties, paste that information right there, and then say OK. Basically, I just copy this text from the file name in my file system without the .pcb 123 extension. I just copy the file name itself. Then I paste it to this field here in the properties field on this text. Or if it's the first time, I just use add text and place it. Then visible, I go to the drawing layer, to the fab drawing. And if you don't have your fab drawing made, you can do generate mechanical drawing on your first, when you first open a design. You don't have a border and all that. So you just do generate mechanical drawing. It will create a mechanical drawing for you. And then this field here is the field that generates the order name that the part number that you're ordering from Sunstone ASC. So again, properties, paste, you paste the file name in there, and off you go. Then, in order to keep track of the revision of your board, which sometimes is pretty important, especially if you're rolling the rev for a minor thing, you can change that here and just add a revision name number. And this is the revision number that goes on the order form. So these two pieces of information, this field here and this field here, are critical in ordering the board and making sure that you order the same file name that you have saved in your file system, so that later on, 6 months down the road, you got a question about this board, you can go back and say, this file matches this design with this timestamp right down to the minute that I ordered, and that's what we're looking at. It can be really hard to look at a board that doesn't have the information tied together like that downstream and say, yes, I've got the right board. I mean, like you may have a capacitor part number change or a foot part change or a routing change that is slightly different from one board to another, causing a difference in performance that it give you the grief. So those pieces of information tied together can be really helpful. And if I have a question for my manufacturing folks, the first thing I say is, send me a picture of the board with the part number showing, and they do. Then I can speak. I'm not going to say intelligently, but at least somewhat coherently about what's going on with the board, and that's the best way I've found to keep track of all this stuff. And this is one of my live designs, so please don't take any screenshots and sell it to the neighbors. From there, we're going to move on to the next topic. I think I've beat that one almost to death. Design changes. Let's say you've got a completed design and you want to make a change to it. I want to change capacitor. Well, a couple things happen when you change a part. If you just delete a schematic symbol and put another one on, and then you come back to your board, your routing's all gone. So if I wanted to replace, let's say this guy here, if I go to my schematic and I say, well, let's do a little bit better. Go to schematic symbol. All right, and it's this guy. And I want to replace it with this guy. So a couple ways I can do that. And the way that typically your mind says, I want to replace this part, I want to delete that one, and I want to put this one in its place. All right, now let's go back to the layout editor. Doggone it, all my routing's gone, and this part is placed off the board. And in order to get it going again, I've got to place this thing somewhere up in here and then reroute it with new signal traces. Well, that's not necessarily always going to be a really lovely thing, because sometimes you're routing all the way across the board, or you've got some critical routing. It's kind of a pain in the neck, or you just don't have time to mess with it, and you just want to put a new part on. Well, if you go to your schematic, let's see what happens here. I want to undo a couple times, and hopefully it will undo. Get us back to our starting point. Okay, got parts back. All right, so I've got my part. It's still placed. It's still wired up. I want to replace it with this one. So what I'll do is I'll put this guy and I'll just wire it up in parallel. All right. And what that does is that gives me a couple of guide wires, gives me a new part on the board. It's got connectivity, and these wires, it knows I want to wire those guys up back to my schematic. Now I can go in and delete that guy. The wires stay. Put that right back where it came from. Go to my layout editor. And all that's left to do is just take this part, plunk it down on those wires, and off we go. It's connected. I've got no errors, no guide wires, no disconnected anything. Everything's done. I've done this with some pretty big ICs that had a different footprint or different, slightly smaller footprint, but the same pin out, that sort of thing. As much as 48 pins, and it works just the same. You don't lose all your routing. So for the bigger parts that are a direct hookup, you can do this for even your big ICs and not lose all that routing, which is, it can save you days of routing if you don't, you don't rip up your entire board. So that's that's how I get to that point. Any questions about that? Matt, got any questions?
No, none yet. Must
Okay,
be doing awesome.
great. One of the really lovely things that can happen, let's see if I would part with more than just a couple of pins on it. One of the really lovely things that can happen is if you are making room on your schematic and you want to just open up some space on your schematic, so you're going to move a part that's got more than just a couple of pins on it, and you want to move it, and you do something like that. It didn't happen. You do something like that, and you inadvertently develop a wire across those pins that you didn't want to have happen. What that does is that gives you a short. Let's see if I can find my part. You get a short across these two pins, and that's a ground to power short, I think, what I've done. You lose a bunch of, or you basically added all of these pins to the ground net, and I don't think that's what I wanted to have happen. Well, now that you've got that wire in there, it's really hard to grab that guy and pull it out and disconnect it from an unintentional connection. These are 2 pins apart, so there's enough room. But if this part was made smaller, these pins were close together, I wouldn't. If there wasn't a separate grid point in between here, I couldn't select that wire and pull it out and then do away with it. But also, if I do away with it, I'm also going to do away with all the routing that went to other things from that pin. And it's really hard to decide which segment I want to delete in order to correct that mess that I made for myself. And this can be a huge problem if you've got a part, like a 24 pin connector or something, and you short 6 pins together, and suddenly you've got 6 nets that are incorrectly named, and it just makes a terrible mess of your net list. So let's put it back where it was. That's something you just have to keep an eye out for. But if you really do want to fix that interconnect that you've messed up, what you can do is you can go back to the layout editor, and again, this made quite a convoluted mess. You can disconnect that pin from the net if that's what you want to have happen, if that's the pin that you want to disconnect. And if it's only one pin that has messed you up, you can disconnect that pin from the net to get rid of that incorrect connection. But on this particular one, I just made a mess of my net list. Shorted those two pins together, pin 1 and 2 of this capacitor. This was the positive side of this. So it was connected up to, not necessarily ground. And I renamed all these pins to attach to ground, I believe, is what I did. You don't want to do that. So when you're moving, just be real careful when you move a part that has more than a couple of pins, that if you move it sideways or across the pins like so, this direction versus just stretching wires, that you don't end up with a wire from pin to pin. Anytime you see that on your schematic, it's probably a mistake. You probably didn't do that on purpose, and it's going to be very difficult to fix. All right, so another thing that has caused me great discomfort over the years is if I want to change the width of a wire, and I think, no harm, no foul. I've got this wire that goes from here to here, and it's, I want to make it bigger to carry more current. No problem. I'll just make it bigger. Well, that's nice, but if I've got, let's say it's, if I can find a good ground wire. Here's a ground wire, and I want to change the width of this ground wire to larger size. I'd say, okay, that wire is 30 thousandths wide. I want to make it wider. One way to do it, if I just want to change this one little segment, is type a W. That gives me the width and a 0.1. I want to make it a monster. 0.1. Okay, that's great. I just changed that one segment on ground. All the rest of them, here's one. All the rest of them stay the same width. That's great. But it's easy to say, well, that's pretty ugly. I don't like that. I'll just put it back the way it was. Great. Now, if I've got a wire that I want to change the whole length of the wire, but not every instance of that net on the circuit board, because it goes, through several parts and does quite a bit of routing. I want to change this wire. It goes up. Come on, let's make the picture good. This wire goes up and across the board and touches quite a few things. I want to change that whole trace. Get it all on the screen. It goes all the way over to that connector. So I can just do right mouse, track width, and I can change it to 30 thousandths, which is great. Goes up here, changes it to 30 thousandths all the way across the board, but it gives me a violation here, creates an error. It creates an error here, which is fine. I can go back and change that, but I have to follow that whole trace, the length of the trace, and then say change this one to make the segment width 10 thousandths, and it still leaves an error because I've got an extra vertex here. So change that one. That fixes all those errors, but I still have to go back and find this other error that I created for myself and fix it. I've got a via here that's too close, and that's the easiest way to fix that is just to drag it up a touch. Now I've got a 30 thousandths wire that's perfectly fine, and everything's good, and no problems, easy to fix. You can follow that one wire. Put it back where it was. All right. But let's say I've got a wire that touches a whole bunch of stuff, and I want to change, and I think, I really do want my entire ground net to be bigger. Net width. Yay. I want to change my net width. And I want to change it to 0.1 because I really do want my ground to be very robust. Okay, great. I got all my pin connections to ground at 0.1. But what I didn't take into account when I did that is that over here I've got this wire ground on my LED circuit that I changed it to 0.1. Well, now it didn't seem to break anything because it's a pretty open area, but you can see how that can cause you some real grief downstream that makes a mess. And worse is if I've got a net that carries a lot of current and I accidentally do that, change net width, and it's got other instances of that net somewhere else on the board, it can create a narrow wire that burns out, just flat won't carry the current you're hoping to carry. Like is present here between these two pins. I've got a nice fat wire and a nice skinny one. And this skinny one's just a sense wire, so it doesn't have to carry any current. This is the path here. But if I change the net width here to, or if this, I wanted to change it to something 8 mils because I want to just route a sense line. It changes this current path as well, and I don't have that. You don't see it happen. It's off the screen, so you don't catch it until you get a puff of smoke when you plug your board in, and then people ask you hard questions. So the difference, you just have to keep track of what you're trying to do and why you're trying to do it, and be careful not to do too much all at once with your commands. With that, we're going to go in and make some power planes. I'm going to increase this board to a 6-layer board, and I'm going to use all right. So inner layer 3. I'm going to say inner layer 3 properties. Inner layer 3 is a power plane. Okay. Can't be undone. All right, that's fine. Now, plane layer properties. This is where it gets sketchy. Let's see, I want to assign ground and AC neutral. All right. So I want to assign ground and AC neutral to this plane because I want to make a split plane. So you get this warning. Read that warning. It's important. All right. What that effectively did is, well, let's just go. Let's do some more. Let's really break it. GREF1. I want to attach GREF1 to this layer as well. Okay, so now what we've got is ground and GREF1 are attached to this layer. And then what you typically would do is you would add a split. So we'll go up and I didn't practice this before I started. Simple polyline. I'm going to make a split plane, and this is super simplified. I'm not doing anything fancy. I got a split plane. Now this pin is isolated from that pin on this power plane layer. Well, that's great, but what I didn't take into account is that there's another pin on this layer somewhere else on the board, right there, probably. That's AC neutral. That's also on this layer. Your tool will not report that as a short. It says your plane layer has multiple net assignment warning. So you have more than one net assigned to this net layer, but it doesn't check your connectivity. So adding more than one net to a power plane layer and then trusting your knowledge of the circuit and where all of the parts are and visual scans of what's going on with your board to make sure that you didn't short your plane layers together adds a huge amount of responsibility to you as the designer that you didn't short something together. And this can happen with voltages. You want to separate half of your board and have it plus 5 volts and the other half of your board 12 volts. Okay, great. You can do this and add the plane layer and split it and keep track of that manually and trust yourself. Or let's go back and just don't do that. Okay, I did away with that terrible plane layer that I created. And let's go back and do the same thing with a ground plane. Just adding a filled polygon on the ground name. All right, so that's connected there, and it did not connect to GREF1. That's a good thing. And then I want to, again, I know that most of my board is everything to the right of this ground pin that I've got highlighted here is going to be GREF1. So I set my select filter to grab polygon, move this guy over. I'll just move the polygon over, grab that, and then I can add another polygon. And I'll just select that, copy, paste, properties, change that guy to GREF1. And it's thinking, it'll get there. Now I've got these two here, 2 planes, GREF1 and ground. And you can see that ground pins are highlighted where they're attached to that pin, to that plane. They weren't in the negative plane layer that was generated, or with the power layer that was generated. And over here, I've got GREF1 that's connected here. But if there are any ground pins, and there are, they're not connected. So that's the way to let the system protect you rather than attaching something that can tie two different voltages or 2 different grounds or a ground and a power all together on the same layer. And believe it or not, we've had when I was at Sunstone, that was one of the most costly mistakes people make, is that they trust themselves to tie, to not tie these nets together on negative planes, or they don't understand the split process, or it just becomes a huge problem, and it can be really difficult to fix later on. You end up with say one GREF pin that's tied to the wrong side. Suddenly your boards are no good, nothing you can do about it. With something like this, if I have a GREF1 pin over here that I inadvertently placed where I didn't, where it's not really connected, I'll have a guide wire that says it's disconnected, and it'll tell me this pin's not connected to the plane. And since all of my stuff's routed on other layers, I don't have that. But for example, here, I've got a ground pin that's tied across this split where I'm going to break these boards off. It's not connected anywhere, and it won't be connected. I'm going to have I'm going to have a guide pin until the end of time on this board, but I know it's there. But if you don't have this, if you've got a pin over on the left-hand side of this that's not tied, and this is the only plane layer or plane that you've got drawn, it will give you a guide, and you'll have that opportunity to get it corrected, move your part over, or run a signal wire, a trace across the board to tie it to this plane. Some way of mitigating that problem. Again, questions? Was I clear or was I mud?
Well, there's no questions in the Q&A section, so either you were great or everybody's being a little shy this morning.
Okay. Well,
If you do have questions, please use the Q&A function. Type it in there and we'll get Bob to answer.
okay. So we are half an hour in, and I've got another thing that has given real grief to at least one really good Sunstone Circuits customer. And I don't remember the exact problem that he had downstream, but what he wanted to do is he had a schematic, and it was really nicely separated into several different segments, and he wanted to just annotate that by putting a polygon around the different portions of his board. So he did. He went and got his polygon thing, this icon up here, and said, let's just draw some boxes. And he drew some boxes around his board and said, that's a segment, and that's a segment, and then that's a segment. These are my sub-circuits, and I just want to put some notes on here to tell them, this is this, and this is this, and this is this. Now, he goes in and he says to himself, that's all well and good, but I want to wire this wire to this wire. And I want to do it like this. Notice nothing's happening. And we went round and round with this, and he just wouldn't, he couldn't get things to work. I want to place a part. Okay, let's just place a part. All right, got a new part there. Yeah, I got a diode. I want to put this diode in here and make it work. Well, I can't wire my parts. What's going on? He says, making me crazy. And we looked and looked and looked and looked and looked, and we could not figure out, because it was such an innocuous little thing. It's pretty simple. Finally, we discovered that these polygons that you can add create boundaries, and they basically lock up your design and make it still works. My board still works just fine. It still does all the things it's supposed to do on this end, but in the schematic, these boxes. So just don't use these boxes. That was a huge thing. We spent a huge amount of time not only trying to figure out what was going on, but once we figured out what was going on, try to figure out how to use the boxes like he wants them so that he could have what he's looking for. And there just wasn't a way to make that work. And that was, that's a little trivia for you guys. If you ever decide you want to draw little boxes and do this thing, don't do that.
Bob, we have a question.
Okay.
How do you view layers in a view-only mode without changes or edits allowed?
In a view-only mode?
Yeah.
There's a view-only mode?
I don't know.
I've never used a view alert mode.
Maybe there's not one.
Well, basically, these should always work. Make a copy of the design and turn off view only mode, if there's such a thing. I don't know that there is such a thing, but just say layer view, and you should be able to turn them on and off. If you don't have rights to save the file, you should still be able to open it and look at it and do whatever, and just not save. That help? Okay, once in a great while, and I want to say once in a great while because I haven't had this happen to me before. Oh heavens, it's been a long time. But once in a while, your design session will, let's just say, exit you ungracefully, and that it will close. You didn't ask it to close. You didn't want it to close, but it closed. I'm not going to call it a crash because that would be a negative connotation. But it looks like a crash, and you end up with nothing going on. Well, let's say you're one of those guys that forgets to save every so often. And I'm guilty. I get in the zone and I work for long periods of time sometimes and just work and don't save. And then it crashes. Oh heavens to Murgatroyd. What will I do? The world is ended. I just lost half a day of work. Well, there is a way. I'm gonna pop to a different window. Let me share that one. Did that share something good? Did that share my file window?
Yep, we got your file window.
Okay, so I crashed. I want to go get my stuff. I'm really bugged. I'm mad at Sunstone because I crashed. You go to Program Data, C Drive, Program Data, PCB123. PCB123 gives you all kinds of good stuff, but the best stuff that I've found is the library and the backup files. Backup files are created pretty much as you're working. This has saved 4 backup files for me working on this test design that I've got here. The last one was at 10:40. All right, 10:40. That's a minute ago. So the worst case is I'm going to lose a minute. And it saved about 10 minutes apart. So I'm not sure exactly what event triggers a save on the backups, but it does save pretty regularly. You can see here 136, 206, 235, 305. So worst case, you're going to lose 15, 20 minutes of work, which is almost always pretty easy to recover, to repair. And you can, if you've done something that causes a repeated, repetitive crash, you can reproduce that pretty quickly, and then you go back and then you do the work that you were doing and it crashes again. You can say, that breaks my world. So then you can call up Sunstone, let them know that you've got a problem that's repeatable, tell them what you're doing, send them a copy of your broken design, and they will go through the steps and almost always find you a solution, or at least tell you don't do what you were doing, which is usually a pretty good piece of advice. So again, it's at C on your C drive, Program Data, PCB123, backup files, and it should be right at the top of the list of your files if you sort by timestamp. Get out of there. Share screen. lost my PCB123. All right. And I'm running out of things to talk about. That went faster than I thought it would. But 43 minutes in, I think that
Yeah.
hopefully somebody somewhere's got some kind of a question I can answer.
Well, nothing at the moment. Any questions from the group? Bob's got a few extra minutes. Anything with your designs that you've ran across or anything he can help you with? I don't see anything. Give them a minute here to see if they're typing. All right. So lots of good feedback today, Bob. Thank you. I think the backup file demonstration was great. I'm sure that can save some people some definite heartache. Though the tool is pretty stable, there are some things that do occasionally create a crash, and like you said, you don't want to lose your progress. So
Right, and even, I mean, a power outage, any of that stuff.
yeah,
If you're in the habit of letting it run, that's, that can get you.
yeah.
But yeah, like I said, it's been a long time since I've had a crash, so I haven't had to use it. But when I did have to use it, it was a good thing.
All right, we have a question.
Okay.
Is there a key that shows what the different via symbols mean?
Please elaborate.
Use a what?
Please elaborate. I'm not sure I understand the question.
So are there different symbols that show up for vias, and is there like a key that shows what each symbol means?
So on this,
You want to share your design again?
lots of vias on this view here. What you can do is you can just put.
Bob, do you want to share your screen again?
Oh, I'm sorry. Got it. Okay. So on my screen, I've got lots of vias. What I don't have is anything that tells me, let's see, properties on that wire. You can basically just select the wire, right mouse properties, and it will tell you what the via that you're using on that wire is. So on this wire, I'm using a trace width of 15 mils is my standard width. Via pad size of 36 thousandths and a drill of 20 thousandths. And that's how this net is set up to work. So if I just go in and drop a via on this net, anywhere on this wire net, it will give me a 20 mil hole and a 36 mil pad. It is, and the vias are not, they're tinted, they're not exposed copper. And then my clearances from other features, 6 thousandths from any other copper feature and 20 thousandths from any non-plated hole. That's basically what you can set up for this wire as a default. I don't think you can go in and change this via. Yeah, you can't go in and change just that via on that wire. So anything on this net's going to be that. So if that answers your question, if you've got two vias that look different, you just select the net and tell it, what have I got here? I think that on my board, all of the vias are going to be the same 20 and 36. Now with component pins, that's a different story. If I want to know about this is a component pin here, and I want to know what's going on with it, I just do properties, and I can find out about that pin. That's pin 7. It's on this net. The pad width, it's a round pin. It's 59 thousandths diameter pad with a 39 thousandths, or 1 millimeter basically, with a 1.5 millimeter pad. And it's at this location, and the parts located or rotated 90 degrees. I add thermals if I put in a area fill on that net. It's going to add a thermal. If I tell it I want it non-plated, it's going to draw that non-plated and take away that solder pad and basically disconnect from that wire. Although the wire will still be there, it'll not have any connection. If I don't want to have a solder pad, if I just want it to be tinted, I can do that. That makes it pretty hard to put a part in it. Or I can make it a slot, which I'm not going to draw a slot right now, but those are the properties you can add there. That answer the question? I get them close to it?
I think that gets it close.
Okay.
All right, one other question. Not a technical user, but somebody that has a question here. We have some quite old 123 files, which we'd like to send out for manufacturing. Can I use the BOM in the software to check for obsolete board components? Or is that just wishful thinking?
You should be able to use your bill of materials. You can dump that to, how old is it? But you should be able to take your bill of materials and save it to a spreadsheet, and then use that spreadsheet at DigiKey. They've got a method to just upload your bill of materials, and it will go through your BOM and hunt down those parts if they're still available or if they're obsolete or whatever. So that'll give you a good starting point.
You said the files are from like 2008. Can we use Snap EDA to
You can
get the
take
tool?
apart. Sure, you can use, well, Snap EDA is not going to necessarily tell you if the parts are available and easy to find. But if you search, you can just take those, save them to a spreadsheet, and take each line item and and copy it to a search window in DigiKey or Mouser or any of those companies, and it will tell you if those are obsolete or not. They'll either find it or not. And so it's pretty quick and easy to do that.
All right, I think that that answered his question. Anybody else? Approaching 11 o'clock. All right, I think we're good, Bob. Thank you so much for your time today. Everyone, thanks for attending our webinar. We'll have another one of these for PCB123 here, probably in November. Keep interested, and we'll talk to you at that point. Thanks again for attending, and it was great to have everyone there.
Yeah, if you run into something that gives you grief, or you just have, you can't figure it out very easily, or you just want to know more about it as well, save that question, and the November session, just bring up the question. I can usually, I've seen lots of things happen here, so I can usually come up with an answer to most of the things that you're going to ask. All right.
All right. Until next time, thank you, Bob. Thank you, everyone.
Thanks for coming.